This is going to be my final video on nephron physiology. In this video, I'm going to be talking about the distal tubule and the collecting duct. Let's go ahead and start with the early distal convoluted tubule. So in this section, just like the proximal convoluted tubule, it's the sodium-potassium pump is going to create a sodium gradient that then drives the function of the channel, or of this cell, excuse me. So what happens is sodium is going to want to move into the cell, right? Because we've moved the sodium out via the sodium-potassium pump. So it will want to move down its concentration gradient, and it will be coupled with chloride. Okay, so chloride is going to move in, and then chloride has a channel that allows it to move out into the interstitial space and the plasma, and then we'll have sodium following. So we'll get sodium chloride reabsorption there. Let's move on to the late convoluted tubule. Okay, the late convoluted tubule and the collecting duct both have three types of cells. They have alpha and beta intercalated cells as well as principal cells. We're going to talk about the principal cells first. Principal cells are primarily responsible for reabsorption of sodium chloride, and they also secrete potassium. But unlike the other cells here, we talked a lot about them being primarily driven by the force created by the sodium-potassium pump and ATP there. In this case, sodium-potassium pump is still the driver, but aldosterone is a big modulator. So what happens? If the sodium-potassium pump is active, working in large numbers, you're going to move sodium out of the cell, potassium into the cell. We have our concentration gradient. Everything's good in the world, and we can do the work we need to do. But that only becomes active in conditions where aldosterone is prevalent. Okay, so when aldosterone is prevalent, that's going to enable that sodium-potassium pump to work, and that's going to then promote the rest of what's going on. So in the presence of aldosterone, what happens is sodium will actually be driven across by its gradient, right? And the chloride will follow. It will diffuse across. At the same time, potassium will be secreted into the lumen of the tube here. Okay. Important to note, the principal cells in the collecting duct do the exact same thing, but they do one additional thing. They also have aquaporins, which allow for water to move across. So this distal convoluted tubule is not going to be permeable to water, but the collecting duct is. Okay. Now let's go ahead and talk about the alpha and beta cells. So inside both of these, there's a carbonic anhydrase. The carbonic anhydrase is going to make hydrogen ions and bicarbonate ions, and that's going to drive the rest of what happens. It's really just opposites in both of these. So in alpha, what's going to happen is our hydrogen ions are going to be pumped into the lumen of our tube, of our collecting duct, right? And that's going to be coupled with movement of potassium into the cell, okay? Potassium will then be pumped out into the bloodstream. At the same time, our bicarbonate will be pumped out into the bloodstream, and chloride ions will be pumped into the cell, okay? And the exact opposite happens for the beta. So hydrogen ions are pumped into the lumen of the tube, chloride is pumped into the cell, and bicarbonate ions are pumped into the lumen here, and chloride is pumped into the cell. And hydrogen ions are pumped out into the plasma, coupled with potassium movement into the beta cell. Potassium in this case will move into the lumen of the cell. So it's going to move across in both cases. And the main thing to recognize here is the alpha cells are going to be responsible for moving bicarbonate into the plasma, right? moving a base into the plasma. So it will be to balance out any acidic, anything acidic in the bloodstream there. And the beta cells will do the opposite. So they're going to move acids into the bloodstream, balancing out any basic material there in the bloodstream. I hope these videos were very helpful to you. If they were, go ahead and give a like and subscribe to my channel, and have a great day.